Hello. All right, good evening. Thanks everyone for coming. Grab yourself another final drink, take a seat, and we'll get started. With the little area at the back, feel free to fill it in with chairs as we go. Is that better? Yep, cool. Let me know if we need more chairs. There's still a few around. All right, did we get through all the pizza? Nearly. The kids will have the rest. Sorry? Yeah. All right, well, thanks for coming. This is the May edition of Melbourne CocoaHeads. I'm going to start off straight away with a really quick kind of recap of the month. I think most of the news in the month happened in the last week, so it's sort of top of my mind, so I thought I'll do that first. I'll introduce myself, some upcoming CocoaHeads and Google I/O GDG related events coming up. Quickly recap our code of conduct, talk through who's speaking tonight, and thank the sponsors as well. So the month it was between our last meetup and tonight, and we're unusually on a Tuesday night. I'm not sure, I could be wrong, but I don't think we've ever not been on a Thursday, and we're in our 11th year now, so this feels a bit weird. So thanks everyone for coming along. We've swapped venues at the last minute before. This is just a day of the week. So in the last month, I felt that the only 4 things that came to mind were the airport's gone. Does anyone have an Apple airport at home that's been doing their Wi-Fi for the past 7 or 8 years? I have 2 in a box if anybody wants them. Vintage. Apple's Q2 results came out. That was 2 weeks of lead up saying the iPhone X is no good, or some of the suppliers aren't selling enough OLED screens to them. Apple's doomed as usual. It turns out that everything is good. Warren Buffett likes it. The most useful thing was he's like, yeah, I bought some more stock. So then it went up again. So I think we've got at least another few years of Apple not being doomed until next quarter. Our Adelaide friends from Pocket Casts were acquired by all the cool radio stations in the US. There was a great follow-up from a lot of the kerfuffle around, oh, you're selling our data and privacy and this and that today on their blog. So if you're interested in their follow-up, it seems like a really great fit. They're a really legit group of people. So if you're into podcasts, Pocket Casts is made in Australia. It's always good to see success there. And that only happened 2 or 3 days ago. And yeah, yesterday or the day before, probably yesterday, was the iMac's 20-year anniversary. And the iMac was sort of geared as, I guess in hindsight, it was the turnaround of Apple, where everything started to have an I in front of it. I think the Steve Jobs presentation back then was before, everything was instantly syndicated and people watched it live. Some good commentary around that. Was he wearing a suit? Yeah, I think it was doomsday back then. It's like, we need to look important.
There's a great article about how magazines retooled their front page, and that was going to be the first news of it going out to the world.
Yep. Anything else interesting happen this month in that kind of context? I thought that was kind of it. I kept all the Tesla-related news out because that's just kind of close to me.
What was it, marzipan?
Oh, the marzipan stuff, yeah.
What's the marzipan stuff?
That was the unified UI libraries.
Oh, okay, yep.
Pushed back to 2019 as a good authority.
Yeah, okay.
As in a PR person called him and said, hey,
Shut up.
this,
Yep.
just so that people shut up.
We might get that unified UI library before we get Mac Pros.
Maybe they come at the same time. Maybe we need a Mac Pro to be able to build on them.
Right. So, if you're wondering who I am, I'm Jesse. Kind of organize the pizza to be delivered and set up my webcam here every month. I've been the organizer since, and the beer. Been the organizer since about 2014. What else do I write up there? And I'm not heading to WWDC, just so you know. I am heading to the breakfast the week of WWDC. We're going to push the next NS breakfast back a week so it sits in line with WWDC, but we'll talk about that in a sec. Upcoming events in coordination with our friends over at the Google Developer Group. I've included upcoming events for May and June. Google I/O is tomorrow morning, tonight, now, happening now. Is it? Yep. So the Google group are running a drinks night at the Mill House tomorrow night, I think to celebrate new Google things. We have our hack night on the 16th, which is next Wednesday. That's our ongoing combined Google group Melbourne CocoaHeads hack night. That's been super fun and super successful. If you've got a little side project on anything, I was hacking on some Raspberry Pi stuff last month. Come along, hang out. We don't have pizza. We have better food. And it's an all ages, no alcohol couple of hours of just hanging out. So it's so far it's been lots of fun. Drinks night is the opposite of that. It's at a bar. It's the last Tuesday of the month, also at the Mill House. And the GDG have an extended meetup on the 30th of May celebrating Google I/O. They're actually flying in a couple of speakers. I think it's actually a bit of a big deal. That's on the 30th of May. That's worth sussing out. In June, NS Breakfast will be on the 6th of June. WWDC is over that week. Who's heading across to WWDC?
Who's going anyway, even if you don't have to?
Who will be there that week? Just put your hand up if you're going to be there that week. There's 1, 2, 3, 4, 5, 6, 10 people. That's not bad. CocoaHeads June is on the 14th, the week after. So come back to Melbourne and then give us a presentation that week. That's a photo from the hack night last month or the month before. Everyone's busy. Everyone's looking productive there. Lots of fun. More info, melbournecocoaheads.com on our events, and GDG Melbourne have a nice website, new website they've put up as well. So head along to there for those details. You can find us at Melbourne Coco on Twitter, slack.melbournecocoaheads.com. You can invite yourself to our Slack channel. There's all sorts of basic kind of little chat rooms in there about different things. Lots of fun. YouTube, we stream everything live, and then I cut them up and republish the individual talks, so you can always check out the last couple of years of stuff there. And if you want to contact me, I'm Jesse. Code of conduct. We have a code of conduct. We put that together at the end of last year, and I think that's been really well received. I think a few other groups have already jumped on and sort of borrowed it, as we borrowed other groups' code of conduct. Pretty much, we want to have an inclusive environment for everyone, regardless of everything, including, where is it, or technology choice as well. So it's sort of, let's just keep everything fun. We have it published on the website, Code of Conduct. You can email codeofconduct@melbournecocoaheads.com if you have any complaints, any issues, want to just check if something's not right. That gets forwarded to a small group of 3 or 4 of us, myself included, where we can help you out with the problem. Confidential, of course. Before I get off and bring Vlas on to do some augmented reality, I'd like to thank our sponsors for 2018. I changed the model around this year and came up with a major sponsor and some minor sponsors, or gold and silver or whatever. And it was really great that I could reach out to the community and get everyone on board. So realestate.com.au have come forward as the major sponsor. Is anyone here from REA? No, that's the 4 seats that are missing at the front. So REA have been a great sponsor over the years. They're also sponsoring the GDG group and a handful of other things. Our silver sponsors, we've got Itty Bitty Apps crew are here. Baloo, there's Baloo crew here. Oh yes, 100% growth month to month. The J-Tribe crew, there's a couple not here yet. They'll be here next month. Cognizant, is anyone here from Odyssey, Cognizant? And Explore, I see a few of the Explore crew, they're back there. So thank you guys for reaching out this year. YBF Ventures is this venue. We've booked in here all year, so this is our home for now, and it's great. We're into the intro and who's hiring. Vlas is up first with his AR kit demo. Oliver's going to talk about strategies for dealing with legacy code. This is Oliver's main topic in general. And Rob is going to talk about Swift on the command line and the Swift package manager. Looking forward to Swift package manager stuff because I've been dealing with Carthage a lot lately and it's painful.
It doesn't replace Carthage, sadly.
Yeah, nothing's going to solve that problem I was having. So who's hiring? If I'm going to go around the room and if you want to just say who you are and where you're from, hang around at the break, you know, and also I will grab your details or at least write them down and put them in our Slack jobs channel. So if you want to put your hands up if you or your company is hiring, and Rob will come around and talk to you.
So if you're in the market, pay attention and then grab them during the break.
Hello. Yeah, it's on mic.
That's the better one.
I'm Oliver. I'll be talking later. Technical director at Itty Bitty Apps, and we're hiring lots of people, anyone and everyone basically, but we're particularly interested in senior roles around. So if you're a person who wants to lead teams or do a senior dev in a smaller company that's full of really smart and interesting people, come talk to me sometime. Or alternatively, just email jobs@ittybittyapps.com.
They're also on Slack if you want to get them up.
All right, down in the middle here.
I'm Alistair from Drawboard. We do PDF collaboration, and it's kind of like Google Docs where any annotation you do is synchronized in real time everywhere. We're looking for iOS developers, all levels. We've got a few of us here. Go on, so talk to us during the break. And yeah, thank you very much.
Anyone else? No, hands up, guys. If you're hiring, just do this one.
What was your name again, sorry? Alistair. Cool. Either way. All right, so that's it for me. Going to jump straight into presentation. So I'm just going to swap over with Vlas. We'll be back in the next couple of minutes. So now's a good.
Refresh your drinks if you need.
Yeah, that's it. Yes.
Actually have the lights on. Maybe get lights.
Okay.
I saw your phone.
It's just, it's not. Yeah, it'll be fine. I think I can work with that. Yeah. Yeah, I think we're ready.
I'm going to move this to focus.
Okay.
So don't worry about me.
Hello. I think we're ready. My name is Vlas, and I would like to tell you about ARKit 1.5. So you may remember the last time I made a talk about AR. That was about the Reveal AR demo making off. And if you haven't seen that, you can catch it on Melbourne CocoaHeads YouTube. And basically, what I was talking about there is combining the powers of ARKit and Vision framework to interactively track a QR code effectively in the scene managed by ARKit, and track its position and orientation so that we could display a sort of a fake representation of view hierarchy that's displayed on the screen of the device. That's cool and all. And back in that talk, I discussed a few limitations of ARKit back in the day and how the approach with QR code actually kind of worked around those limitations. Now, I think a month ago, iOS 11.3, is that it? Came out with bundled with ARKit 1.5. And with it, it brought a few interesting things. First of all, finally, we can now detect vertical planes. That was actually something that you could see, you could have seen in the documentation for one of the first seeds of iOS 11.0, but then it was kind of silently removed. It's like, oh, no, we don't actually have that. The other very interesting new feature in 1.5 is that now you can actually detect images in your scene. You can provide reference images, and ARKit will detect them in the world around you. And these two are, in my opinion, are two major features of 1.5, and there are also a few interesting minor features, I would say. For plane anchors, instead of only having access to information about the extent of the plane, the width and height, you can actually get a corse mesh geometry. So that, for example, if the object that ARKit has detected is not a perfect plane, which is it's not always, it will give you a coarse representation of the shape of that horizontal surface or vertical surface now. And you can use that to actually hit test against not the extent of the plane, but against that coarse geometry. Camera can now use autofocus mode, which is actually enabled by default for applications that link against ARKit 1.5, which is pretty useful. You can now also choose a capture format for the camera, so that, for example, if you prefer a lower resolution, you can choose that. You cannot actually specify like any values. You have to choose among the list of supported values. And for example, on my iPhone 10, I think the resolution the formats to choose were either 60 FPS Full HD or 60 FPS 720p. And you can also opt in to automatic session relocalization. So for example, if there was an interruption, maybe like an incoming phone call, but you were mostly standing around in one place, the application can now, well, ARKit can actually try to relocalize the session after this interruption. So it will try to hold on to the feature points it knows about and restore your session without having to reset everything. So a bit more about the major features. So vertical plane detection. It's, yeah, it's back after leaking. It's basically the same as horizontal plane detection, but vertical, right? Very good for IKEA app, I'm sure. And you would think that it should be good for something like walls, right? Well, there's just one little caveat. Vertical plane detection has the same kind of limitations as the horizontal plane detection. which means that if a vertical surface doesn't have enough texture to it, feature points for ARKit to grab onto, it will not actually detect it. And as you can see, most walls are actually the same color. So how exactly this could be useful for walls, I'm not sure. Maybe outside, outdoors, where maybe you have brick walls or something, absolutely. Indoors, maybe not. Reference image detection, I think it's, in my opinion, the most exciting feature of 1.5. So you can supply images, the reference images, and their real world size when starting the session in a form of either CG image, so you can effectively create those reference images in runtime, or you can just specify pre-baked images from your asset catalog in Xcode 9 point whatever it's these days, supports adding pre-baked reference images for ARKit. What's cool about this feature is that it actually allows you to detect images at any orientation, kinda. So it's not tied to your plane anchor. It's not tied to specifically horizontal or vertical planes. It's smart enough to actually detect images that are somewhat rotated. There are limitations, obviously. And it can also detect partial matches. So for example, if you see, if the camera can only see, let's say, not sure about specific numbers, but let's say 80% of the reference image, it can still detect that. And as you may have seen from Apple's PR material, the primary use case, in their opinion, and that makes sense, for this feature is, for example, showing some kind of interactive AR scene or something in front of like a painting or some exhibit in a museum. So you just, you walk around the museum, you see some image, it's actually a reference image in the app, you point at it, and it like blows up into something interesting. And yes, it will actually also update the image anchor detects if the reference image in the real world actually moves around. If it's not a static painting on the wall, if it's something that's dynamic, it will update the position and orientation. And with that, uh-oh, no! Technical problems. How do I do this? Okay. Let's get back to that. So, how does this all connect to the Reveal AR demo? So you may remember that it was using a QR code tracking using Vision Framework to track the screen in the world. So image detection could actually replace that in theory. And there are some pros and cons. The pros are, well, we don't need to cover the screen with a QR code, obviously. It works at reasonably, with different orientations. At a different angle, it will still detect that, while the previous demo could only work if the QR code was actually on the plane that it already detected. But unfortunately, it's also slightly, well, somewhat less reliable, just because, well, previously, Vision Framework could detect the QR code with a certain errors, effectively, with certain noise in the picture. The images are a bit more finicky. It might not pick an image right from a screen. The main problem actually there is because the screen may have a higher brightness than the surrounding world, which means that the image from the camera may be overexposed. Yes, so that would block ARKit from working. And then the position and orientation updates of the image anchor are around 1 second or maybe half a second, while if we use Vision Framework, we control how often we actually update the anchor information. And then, yes, well, you actually need an image, an up-to-date image of what you're looking for, and that image carries no actual data, while if we detect the QR code, we can actually extract some data from that QR code. So yeah, there are pros and cons. And well, let's take a look at that, how that works. So I will start with using my iPad for this purpose, and you can see once it loads that it actually works. It has detected the image. I'm enabling this debug mode, and you can see that this red rectangle is the detected image. So in this case, it actually worked pretty well, maybe because the brightness of the iPad and the surrounding lighting condition is good. So that's the image detection. I was also playing around with using the QR code itself as the reference image. Whoops. Let's put it back into its state. Yeah, I can see that the image is not highly saturated. Come on. Whoop, there you go. Oh, that's actually the original mode, just for reference though. So here's how it tracks when it's using QR code, but you can see that there's still some glitching going on. On the other hand, if we're using image detection, loading, there you go, it will still work, but it's a bit more glitchy. But on the other hand, you can see how it works under the angle. So I can rotate the iPad, and it still pretty reliably detects that image. Even as the image rotated, it detected the rotation. Whoop. And it rotated itself. So that's nice. I was actually playing around with an alternative, and that is using actual printed screenshots. And you know what? It also worked. In a different lighting condition, it could actually work better. There you go. Detected the image. And it still works. I should probably collapse it slightly. Well, that's kind of about it. And in terms of vertical surfaces, I'll just quickly show that we have this box. It is effectively my vertical surface, and it has detected this coarse mesh. It's obviously not very precise, but it's something. And well, not sure how well that would work. There we go. It has appeared. So obviously this white overlay shows the geometry that ARKit gave me. And I think that mostly covers the features of ARKit 1.5. I guess the outcome of that is, for me, that the QR code tracking approach, I think, still has its own uses because of those different pros and cons with image detection. But if you have something in a physical world that can be represented as a printed image or a picture, that's definitely more useful. I think that's it. Any questions? Okay, there you go.
Just to clarify, the image you're using is the full UI, that full thing, not part of that?
Well, yeah, this is just a screenshot of a Soundstagram, an app, it's an app we ship with Reveal. And yeah, it's just an example, essentially. Anyone else?
You compared ARKit with Fourier performance with current tracking.
Oh, compared with the what, sorry?
Fourier? Like AR library that helps.
Right. Okay, no, I haven't tried that. I've only tried ARKit. And by the way, speaking of which, so I've just run the ARKit for app, with 1 or 2 or 3 reference images and some extra processing. And my phone has hit it up significantly, to be honest. So, yeah, keep in mind the battery drain when working in AR. Yeah, performance can actually vary. It all depends on the lighting conditions, depends on how many feature points you have on the screen, how much you move around. But no, I haven't compared with other solutions.
So usually walls are not well lit, so how do you find that with a vertical?
So as I mentioned, I don't think walls are a good example of vertical surfaces that ARKit right now with the current hardware is good on. But maybe at some point, maybe Apple will release a phone that actually has a LiDAR on the back that actually performs scanning of the world around it, and this way, obviously, detecting vertical surfaces would be much easier. Well, I say much easier, as if it's like not rocket science, right?
How does the code differ between the two approaches?
You mean the image reference versus the QR code? Obviously, image reference tracking is much simpler because you just specify the image itself and the physical size, and you will obviously need to handle a different kind of different kind of AR anchors, the image anchor. But apart from that, yeah, image anchors are much easier to deal with because you don't have to implement any custom code essentially. Oh, there you go.
How do you do to put like an image anchor, like some kind of like to get the pattern of the image you want to?
Now that's, I don't think that is possible right now. So essentially you need to specify a precise representation of the real world image that you would be looking for. Hopefully in ARKit 2, I'm hoping that there would be something that would allow us to use custom techniques, maybe, for example, even a marker detection technique, because I've seen that inside the framework. It's still not exposed. I'm like, okay, I'm waiting patiently. But I'm hoping that we'll be able to either somehow customize the detection, or at least we'll be able to detect the classic traditional AR markers, like something you may have seen if you were dealing with older AR libraries. Anyone else?
File a radar if you have a use case.
Yeah, good point. Yeah. Anyone else? There you go.
How tolerant is the image detection, right?
Right.
So could you take a photo of, like, say, an outside scene and a few, there's people in different spots and things like that. Would you still be able to detect based on it?
So first of all, the image that you're looking for needs to be flat. It's not looking for like shapes on there. It's looking for a flat image. I'm sure there's some processing involved that allows ARKit to detect partial matches, and I think I can show that. Let's try and restart that. If it doesn't crash, now it's crashed. I've had a precondition somewhere, and now it crashes. It's like, that's just what it happens. Okay, so I'm not, oh, there you go. I've been pointing at just half of the image, and seems like it was enough for it to detect the whole thing. Because it knows the physical size, it probably has detected the center, and it gives me the whole thing, which is pretty nice. I'm sure the more reference images you have specified, the more difficult it would be. I didn't check one interesting question, and that is how many reference images you can specify until the performance just drops, it becomes unacceptable. That I didn't try. But as you have seen, on a like average lighting conditions, half of the image was enough. Maybe it is just enough texture in here to detect. Maybe. There you go.
Are you able to experiment, just curve the paper a little bit and try?
I can try that. I'm pretty sure once the surface becomes not flat, it becomes much more difficult. Okay, pretty sure I was mirroring. Okay, so I'm.
Just tell us.
It's problematic, yeah. So once you curve the paper, it becomes more problematic. So I've curved it a little bit. Well, with this kind of curvature, it's okay. It really depends on what ARKit is actually looking for in the image. It may be reliable enough for simple curvature, but you can see how, it won't work all the time, effectively. Pictures are the best ones.
Which detail does it need in the image?
Now, that I don't know, to be honest. I've only been experimenting, like I only been collecting empirical data here. So as you have seen, it's like half of the image was enough. By detail, do you mean like resolution of the image?
I mean, like how much does it need to find? Like if you took images of people's like body shape, would it then pick that up as being something you project onto?
So as I've said, I don't think that shapes would be something ARKit would be good at detecting. So I'm pretty sure it's looking for colors and maybe feature points. The implementation is not exposed anywhere in documentation or elsewhere, so I don't actually know how it works specifically. Though using Hopper might shed some light. But yeah, I'm pretty sure it'd be looking more like on a texture. So if you have a human wearing one kind of clothes and another kind of clothes, those would not be the same from ARKit's perspective.
Give it a go.
Sorry, what?
Give it a go.
I suppose, yeah. Anyone?
For the vertical plane detection, do you need better performance out of the front-facing camera, not iPhone 10?
I didn't try that. I'm pretty sure front camera is not designed to work with that, simply because the true depth camera is designed for this kind of distance. So once we get true depth camera on the back, absolutely. For now, I'm pretty sure it's mostly designed for face anchors. Actually, it's possible that if you're using frontal camera, it just doesn't detect anything else other than face anchors. Maybe next year.
Have you had a chance to try the runtime image?
Try what, sorry?
The runtime. You said you can add to a set, or you can put the CG image as the.
Oh yeah. So as I mentioned, you can definitely specify a image in runtime. That's what I'm actually doing. Yes, you can pass CG image and the physical width. It will obviously take the aspect ratio of the CG image and calculate the physical height from that. Yep.
You actually can download from like API.
You can. You definitely can. Well, I think, yeah, images are not code, so that should not be, that should be allowed as per App Store guidelines. So I don't think anything would be stopping you from doing that. Which is nice, actually, because I remember this friend of mine who's working in a similar field, and he was talking about like hundreds and thousands of different artworks. And I'm like, how do you manage that sort of complexity? But turns out he is actually doing that on the back end. And so I thought, well, you could, in theory, do that with ARKit as long as you somehow can isolate the set of reference images to like a particular location. Maybe you enter a museum and your backend maybe tells you what particular set of images to use, or even maybe you can download those images, but then like how many megabytes would that be? That would be the question.
Do you have control over the memory? Like if you download image on runtime, do you have the entire clear out?
That's what I didn't try yet, as in how many images you can specify to the session until performance drops. But, well, it's not magical. I'm pretty sure. I wish it was, but I don't think it is. So I'm sure there's some limit. And I don't think it's above 1,000, maybe even 100. But don't know. Don't know, to be honest. Anyone else? Thank you.
So it's on mute at the moment. Oh, that. Yeah. Frame. Boom, boom, boom. Test, test. Hello. Hello, everyone. Everyone settle, get the drinks. All right. Okay, so yeah, about a month ago I mentioned in the speakers channel that I would had a talk, and it was going to be strategies for dealing with legacy code. And that's because I'd been dealing with legacy code quite a bit for the last 12 months. And I thought I could gather my thoughts together and create a talk out of my thoughts. And I was wrong. So actually this is going to be a bit of a story about a specific code base that I've been working on, where it was 12 months ago, what I've done with it, and kind of where it is now. And it is a legacy code base. So I'm going to set the scene a little bit. So there's this thing, there's the monolith. Back in 2017, March 2017, I was contacted, or we were contacted at Itty Bitty Apps for me to come in to a bank. I'm not going to tell you which bank, but you can probably guess which one. And to help them build a new banking app to replace their current one. Or it kind of was. We actually were going to repurpose an existing app that they had and make that the new banking app. So this existing app, the code base, it's all Objective-C. We had about 2,500 lines of Objective-C, or files, sorry, about 193,000 lines, about 5,000 lines of Objective-C++, about 86,000 lines of headers, and 1,500 lines of Swift. Someone had snuck that in somehow.
How does Objective-C++ fit in?
When you want to interface with GSOAP, GSOAP is a C++ library.
You don't want it.
No, you don't. Anyway, so it's old code. Some of the code goes back to 2012, 2013. It has had many hands in the code. I did a little git log check on the code base for all the authors. And yeah, up to that point in March of 2017, there'd been about 60 devs, plus or minus a couple and a few bots.
Is that the real diversity?
Yeah, it is, and that's me guessing. Actually, I only recognised maybe half of the female names, and the others were from areas unknown. But maybe they might have been female names, so I counted them as female. They could be boys. Yeah, so not great for diversity. Funnily, Chris Venter, now you'll know where this bank is coming to talk about diversity on Thursday. Anyway, that's that then. Now, a year on, about 110 developers have committed to the code base. So that's 50 more in 1 year. So that's interesting. Not all necessarily developers, a lot of testers as well, automation testers. Anyway, so this code base is very had a project-driven development model. Money is budgeted, devs get to work, they work hard, they hit the date, and then they wave goodbye. So that's probably why you had 60 devs. Though some of these projects were pretty long, like multi-year projects, but it was definitely a bit lumpy, let's say, the code base. Anyway, the codebase is made up of an application, a watch extension, today view extension. It had 11 networking and domain foundation-oriented modules, 21 UI libraries or UI support modules, seven core functional area modules for banking, superannuation, insurance, registration, stuff like that. They weren't the pods. They weren't the third-party libraries. These are the internally developed things. If I added the pods in there, it'd add a bunch more. So about 38 of these modules. They were originally CocoaPods. If you were here a month ago, you might have heard me talk about lots of CocoaPods and as a question to one of the Zero guys. Anyway, previously the app had been through a sort of, so all of these, they had lots of CocoaPods that were internally managed and that created a nightmare. So someone had the smart idea of bringing it all together into a monolith repo. And so it basically been through a process of depodding, but no one had bothered to reorganize the files. So they're just in directories in the codebase. Anyway, so as I said, in directories. The file system was pretty much a mess. Lots of inconsistencies in folder layout, and particularly inside the modules, like every pod seemed to have a different way of laying out its file structure. Third-party libraries that I haven't mentioned, the number of, a lot of them were out of date, unmaintained. There was no obvious project architecture in the coarse grain, like areas of the app, depending on which projects had adopted certain design patterns and certain architectures within their areas, but not globally across the entire application. And nearly all the code was Objective-C, and the developers, a lot of them felt like they were being left behind by Swift, because this is in 2017, right? So Swift 3 was already out. And someone had snuck in like 30 files of Swift somehow. I wasn't blessed. Just adding to the build time and the size of the app. Anyway, so problems. There were very coupled code, a lot of header dependencies, a lot of hidden header dependencies. Thanks, prefix files. Yeah, don't ever use a prefix header in your codebase. Not that you should be really using Objective-C much now, but if you are, unless you're doing C++, don't use PCH files. They are the devil. Developers could import anything from anywhere. Now, this is a bit of a problem with CocoaHeads, CocoaPods. CocoaPods, yeah. I hadn't really grokked to this until recently. It was mentioned in the release notes, I think, for CocoaPods 1.5, where they introduced Swift static libraries, where they had to rework the way that they did the header includes for CocoaPods, or the include paths. But basically, I think, if I'm reading what they said right, when you're using CocoaPods, essentially all headers are public, well, at least the ones you make public in your pod spec. And you can include any other pod's headers in your particular header. So that may have been a problem beforehand with the CocoaPods, the internal CocoaPods that this bank was using, but it definitely became a problem more so when all the pods were brought together and everyone could just basically hash import this header because it's got something I want. Yeah, and the other problem was there was a long build and test cycle on the app because 2,500 files and a bunch of C++ that takes a minute to compile. You've got a big long build, and so if you change the prefix header or anything included by the prefix header, you have to build everything again. And so the test cycle time was pretty slow. People hated writing tests. And yeah, it was not a good place. The other major problem I had was singletons. Singletons everywhere. Which brings me to a rant.
How long have you had that slide?
I actually went to Meme Generator yesterday and made that, but I'm sure it was probably there. Yeah, anyway. Okay, the rant. All right, singletons. I'm going to read what Wikipedia says. The singleton pattern is a design pattern that restricts the instantiation of a class to one object. This is useful when exactly one object is needed to coordinate actions across the system. Whoops. Okay, so the keywords here restricts the instantiation. This is kind of a parenthetical afterwards. It's like, oh yeah, and you also have to be able to access that instance. So it's like, how do we do that? Oh, well, it's global, so you know, it's convenient. But the pattern, like, it's not the primary intent of the singleton. The primary intent of the singleton is that it is a single object. You cannot create more, or you shouldn't create more. So, more for Wikipedia. So singletons, considered by many, including myself, to be an anti-pattern in that it is frequently used in scenarios where it is not beneficial. It introduces unnecessary restrictions in situations where the sole instance of a class is not actually required, and it introduces global state into your application. So singletons were designed to avoid the situation where you don't want to create more than one instance of a class. Okay, the intent of the pattern is not necessarily to create a convenient way to get at something global. All right? Because we all know globals are bad, right? Right? Shared mutable state is the devil. Don't do it. Okay? And if you don't know why globals and shared mutable state are bad, that's okay. But please read up on it. I'm not going to explain why. Okay, so what is an actual use case for a singleton? Well, a physical serial port might be one. I'm not talking about like modern Unix systems which have serial devices or other devices modeled as files, where you can use file locking to avoid accessing them simultaneously. But maybe on an older type of computer, a DOS one maybe, or System 7 Macintosh. Maybe it uses memory mapped I/O, right? And so anything in an unprotected memory, like a System 7 Mac or a DOS PC, can write to any memory anywhere. So in a system, you might want to write a wrapper around that memory, which you can only allocate once. So you can coordinate access to it through that thing so that you don't write random bytes in random order out of your serial port from different parts of your application. All right. So you've got to remember that these design patterns were written in the 90s, right? So this is the sort of problem they were trying to solve. Anyway. So the other things that might actually be singletons, but aren't modeled as singletons. So on your iOS device, your modern Unix-based mobile phone, you have a GPS. There's only one GPS, as far as I know. Renault might know better. And it's managed by a daemon. And that daemon is a single instance, obviously, but it's managing the device. The way you connect to it is through core location's CL location manager. But you can instantiate as many of those as you like. And you can access it in a variety of different ways. But it's ultimately providing you access to some single resource. But it's not modeled as a single resource. So you don't have to either. Anyway, so Singleton alternatives, obviously, sometimes you can't avoid them, but even if you do have them, you can at least use dependency injection to get them into your code. So you get better testability, and you get the ability to refactor easier. Just because the OS provides default singletons, you don't need to use them directly either. You can inject those. And just because iOS provides a default notification center instance for the system notifications, it doesn't mean you have to use that to broadcast your own notifications. I don't know if you've ever noticed, but you can instantiate notification center yourself. And that means that you can do things like internally within your own framework or your own application, use a private instance or your own instance of notification center to broadcast your events if you're going to use notifications for multicast broadcast or an event bus or something. And they don't mix up with the system notifications. It means you don't get a performance penalty, not that that's significant these days, but yeah, it gives you other options. So think about that when you're wanting to use things like, NS notification center default and so on. All right, end of rant. So what are the solutions to my problems on my legacy code base that I was dealing with? So I'd inherited this messy old code base loaded with singletons, and I needed some solutions to try and sort of rationalize things, make things better. The first thing I wanted to do was at least have some sort of target architecture. So from this diagram, hopefully you can see it, it's a pretty simple idea. It's to layer your application in architectural layers, right? So that you have an idea of where to stick things. In this case, we have a foundational layer, we have core networking, core domain model, some domain-specific network clients, UI kit, an extension support library, application support library, a legacy library, we'll talk about that later, identity support library, and near the bottom we have banking, superannuation, customer support, insurance and investments, and we have an application, a watch extension, and a today view extension, which are the things that the OS actually runs, right? And the imports all go this way. They can never go that way, and they can't go that way or that way. So obviously core networking can import foundation. It can't import the domain model. But the domain-specific network clients can import core networking and foundation and the core domain model and use them together. But they can't talk to the UI kit. And I'm not talking about iOS's UI kit, I'm talking about like your own private widget library. And so on and so forth down the layers. So this is obviously more important in a big project, but in a smaller app, you might have a smaller scale version of this. It provides an encapsulation model, right? So it's encapsulating all of the stuff related to the core domain model in that model. And so if I change anything in there, like I could have that all be Objective-C, and then one day I rewrite it all in Swift. And as long as I'm exposing the same types using Swift to Objective-C bridging, everything should be fine. I don't care, like nothing outside of it should care that I refactored the entire contents of it. It also, by having that encapsulation model, you're effectively limiting the blast radius of changes. So if you go in and you change some aspect of things in there, if it's not public, it shouldn't matter. I mean, obviously the behavior changes, it might matter, but if you are refactoring without changing the behavior, it shouldn't matter. It also means that if someone does something really dumb, or something suboptimal, as Blast might say, the impact, especially if it's not public, if it's not a public symbol, isn't so great. It doesn't leak out into the other areas of your application. Like people don't see it. They're like, oh, that looks nice and interesting category on string, I'll just use that. All right. The other thing that was a major problem with the project was the file structure. So just progressively reorganizing it, doing it, creating, it's a pretty, DexSet's really bad at some things. But anyway, it's the outline of the basic structure of the project now, not then. Configuration documentation, each application level target has its own directory. Inside that has configurations, tests, sources, resources, and so on for the frameworks. And then you've got pods and scripts and tools and things. And so, and that's consistent, making that consistent across your entire project. So the reason, some people might go, why do you care about that sort of thing? Why do you care about why the file system looks a certain way? Well, it's because architecture isn't just about picking MVVM or MVC or MVP, right? Architecture extends to your entire project. It's how you structure your project on disk even. It's how a developer finds their way around, figures out where to put things. You want this to be as consistent and obvious as possible. And maybe enforcement is a good idea. So in several projects now, including this one, we actually enforce the structure. So if you deviate as a developer, you create a new directory, for example. If you create a subdirectory in sources, the build breaks. You can't do that. You're not allowed. Yeah, and so where you put in a resource file in the sources directory, just breaks the build. Obviously that's, you know, whatever standards as a developer or as a team lead you want to set, you can do that. You know, I'm not necessarily saying my way is the only way, but it is a good idea if you want to have a standard to have some sort of measure of enforcement. The other thing we did was remove a lot of the third-party legacy libraries. We either upgraded them to the latest source compatible version if we could. Some of them we just effectively adopted into the project. There was just little point in maintaining them as third-party dependencies because they might have been used in one place for one thing. Let's have 100,000 lines of code to display a graph once. So, you know, stuff like that. And in the process, we might have renamed a few things, like particularly around small libraries, like Facebook's KVO controller got imported and renamed because it was used once in one view controller. The other thing, of course, we did, which is alluded to in the architecture diagram, was we introduced a lot of frameworks. We started building frameworks. The code in these frameworks obviously could be Swift and Objective-C, which let the developers finally start coding in Swift. And we started moving what we thought was clean enough code into some of these frameworks. But that was really quite slow. And part of the work also was trying to redevelop some of the base foundational bits and pieces to replace the legacy systems in Swift to give it a bit of a nicer, cleaner, shinier look and feel. But as I said, moving the code that we considered clean enough was quite an arduous task because you had to do a lot of things like nullability auditing and enforcement. Yeah, so fortunately, Swift gives you a lot of, well, Swift and Objective-C library, Cocoa generally, they give you a whole bunch of tools for dealing with what we might call legacy code, legacy Objective-C code, and then bringing that into Swift code. So I assume, how many of you are familiar with these things? How many of you are not? Okay. So these are macros mainly on the C, Objective-C side of things, right? So init assume non-nil begin and end helps you avoid having to annotate everything in your header files as nullable or non-nullable. Sort of a blank slate, you can just say bang at the top of your header, bottom of your header, and there's a few built-in special cases that it opts out of, things like errors and stuff are always nil or nullable. And that's great because it makes your APIs easier to consume, or your existing APIs easier to consume in Swift code because you're not dealing with optionals and what have you all the time. But it's kind of shit if it's actually not the case, i.e. your code can accept nils or if it, you know, stuff like that. So really, if you're going to audit or say that your code is non-null by default, you should really enforce that. So within the code, all the parameters that are expected to be non-nil, you should have a parameter assert stating that. And I would encourage you not to disable asserts in release mode. But anyway. The other nice thing you can do, obviously, is rename things. So if you've got some horrible prefix on your code, for example, and you don't want that in your Swift, you can use any Swift name for your classes to rename the class, remove the prefix. You can use any Swift name on properties and functions and so on to give them more Swifty style names. Drop lots of the withs and fors and things. We'll move them around in the method signature. If you want to tweak it a bit. And of course, on the other way around, if you want to expose things to your Objective-C code from your Swift code, using the add Objective-C annotation is required now, unless you've tweaked your build settings. And that can take parameters to give you a more Objective-C name for your Swift property or function. And then, of course, if you really want to mark stuff in your legacy Objective-C APIs or whatever that shouldn't be used at all in Swift, you can mark it in as unavailable for Swift. You can use it as unavailable to mark things that are not available in Objective-C as well. and you can of course use it NS deprecated to generate lots of warnings. And NS refined for Swift lets you sort of rename a method in a way that lets you wrap it in a Swift version in your Swift code. And you should always be using designated initializer macro to mark your designated initializers on your Objective-C code so Swift makes intelligent decisions. The other thing, as I said in the beginning, was a big problem in the code base is this massive build and test cycle. And the great benefit of using frameworks is that you can move the tests into the framework. So for all of the code that belongs to a particular framework, I was lifting it over, using git move, moving it around, doing lots of basic file manipulation and project manipulation, and moved all the unit tests in there as well. Set up a test target for that particular framework, run those tests in that framework. That was a fun thing. It found lots of bugs, lots of interdependencies and flaky tests because mutable state between tests, that's cool. Yeah, but anyway, that did, however, help greatly in the testing of this process of reorganizing all the code base into a bunch of different frameworks because it let me run the unit tests for that specific framework to see whether I'd broken anything. Yeah, so just basically having tests in your frameworks helps you test your software better and faster. On the Objective-C side of things, you really want to minimize the amount of public API you put in your umbrella header. So if you've got a framework which is primarily Objective-C, there's probably a lot of code in there that actually isn't public. Like it's just, you've got a view controller, it uses a view or something else, data source or some other helper controller. And that's not really public API. And so the header for that thing doesn't need to be in the umbrella header of your framework. So you got to be picky and choosy about like what actually gets exposed into your in the umbrella header. And sometimes that means you might need to chop up header files and things to limit the visibility of certain types. And really ultimately the umbrella header on a Objective-C framework gives you access control for Objective-C. It doesn't actually truly make the symbols private, but at least you can't see them by default. So one of the frameworks in that architecture diagram that I showed before was called Legacy. And this is something we did relatively early on, after we realized basically that trying to audit code and move it around was going to become a massive piece of work. And so it was basically a halfway house for all the legacy code. It enabled the sharing, so there was a lot of different modules that used certain things, and we want to break those apart. But if they're using they're using a shared symbol or shared type, we need a place to put them for it to be shared. So we created this legacy framework, which kind of became a dumping ground of everything that was shared by all of the other legacy code. So this really helped us accelerate the creation of the other frameworks. I don't think, I'm nearly done on this particular mission, and I don't think it would be possible for one individual to do all of that without something like this. It would just be too much work. And it kind of, gave us a blessed location to put the shared code that hadn't been audited, that might one day, if it doesn't get replaced by something else at some point, it might get blessed as being, oh, this actual code, this we want to keep, we'll put that in Foundation or UIKit or the domain library or something like that. It's primarily Objective-C and primarily not wanting to be exported into other things. So one thing I have contemplated but haven't done yet is actually make importing of this library into Swift a lint error, so you can't actually import it. I think the boat might have sailed on that. People are already using it. But anyway, so APIs, if you've got, I don't wish this particular mission on anyone else. But if you ever had to or wanted to break up your app into frameworks, there are a number of APIs in Cocoa that might cause you problems. And they kind of have a bit of a theme, and those are really around implicit bundle references. So APIs like UI image, image named, and image literals, they only search the main bundle by default. So if you're moving your assets into asset catalogs within frameworks, which works fine, you are going to have problems because those APIs return nil, and if you then feed that into Swift, it's not expecting it, it's going to crash, or you're just going to have missing icons and what have you in your app silently, like normal Objective-C code doesn't warn you about this sort of situation, just doesn't work. What you really should be using instead is this other API, which has got more parameters, image named and bundle compatible with trait collection. And that obviously gives you the option of passing in a bundle. And what I tended to do is actually just create wrappers around all of the assets. So I create a category on UI image and for all the assets that are in a particular framework, and then replace all of the stringy access to those APIs with these category methods, which were strongly typed and crashed if they didn't find the image, because that's a program error. Like if an image doesn't exist in an asset catalog and you expect it to, you should crash. You shouldn't just blithely carry on with a nil pointer to UI image. So just generally avoid stringy APIs if you're working with frameworks. So the other places where you have implicit bundle references are things like init with libname bundle, UI libname with bundle, and NS localized string. So often people will just pass nil in here for bundle and in here because they just expect it to search the main bundle, and you don't want that. And the default macro, at least on Objective-C, doesn't mention the bundle for localized strings, but there is an alternative you can use, and obviously in Swift, it's got default parameters and stuff. And otherwise you're constantly searching the main bundle where your resources probably aren't. A better approach is to use the class name. In fact, this is the default behavior internally within UI view controller. When you pass nil for the nib name and nil for the bundle, it searches the main bundle. But you pass nil for the nib name, it searches for a nib that is the same as your class name. So you can mimic that behavior by just using NS string for class and NS bundle for class. But in that case, search the framework bundle. And the same goes for UI nib. The other place where things fall down is explicit bundle references. So lots of people like using main bundle in their code for some reason. Sometimes they pass it into the functions like those ones. Whoops, where am I going? Wrong direction. Loading nibs using the bundle, which is an ancient and avoidable way of loading nibs, but people do it. They are, it's off the bundle, so you can obviously replace the bundle that it uses. What we tended to do was create a helper which created a static method on bundle to locate the particular framework. And that helped a lot. So some things did help in this process. As I previously mentioned, tests helped a lot. Fortunately for me, the project had a wealth of unit and UI tests. Not all of them great, but they were there. So these tests made me much more comfortable in moving the code around and refactoring. The UI tests also helped a lot. They caught a lot of errors and issues that the unit tests didn't catch, particularly around the resource loading and nib loading and things like that. And without these tests, my job would have been much more scary, and I would have had much less confidence that I could actually pull it off. All right, now when you're moving code around a lot, what you find is you end up in sort of cyclic dependency problems. where you have A needs B, B needs C, C needs A, stuff like that. Or even just simple things like I'm moving a whole bunch of code out of the main code, main project target and into a framework, but it's depending on code that I haven't moved yet. And this is where dependency injection and replacing some of these singletons, because often these dependencies were just singleton dependencies, like they're essentially saying, oh, I need the account broker to do something, and I'm just going to access its shared instance over here in some random view controller. And so I came up with a little bit of a strategy for fixing some of this in some places. It was a bit inconsistent across the code base that I mentioned, so I had to kind of adjust my pattern as I encountered different ways of doing things. But the basic principle is this way. So you might have, we've got the application target and it has the account broker in it. Admittedly, this thing probably belongs somewhere else, but at the moment, that's where it lives. The superannuation framework, which is newly created, for example, it's not actually the case in this particular framework, but we're using that. There's a view controller that wants an account broker. Maybe it wants to be initialized with it. Maybe it was originally just using it as a singleton, because it's a singleton. Doesn't need to be, but it is. And so the challenge was, okay, how do we fix this? How do I make it so superannuation framework that can't import the application because it's on the layer below and shouldn't import the application? You can't. It needs to still use it. So the solution is create a protocol. That protocol has just the subset of functionality from the account broker that the superannuation system wants. And then because the superannuation system in a variety of places wants to use this as a singleton, and I want to change as little code as possible, I have to create another singleton, which hurts what I do. But this singleton is a bit different. It doesn't instantiate itself. It expects to be given an instance to vend. So it has a static method configured with superannuation, a super account broker, and that is of type super account broker protocol. So wherever the account broker existed in this module, I've just replaced it with a protocol, and I've created a vendor for that singleton where it's needed. So the idea being to isolate and encapsulate the behavior into that framework. The other thing is that I'm now expressing the behavior and needs of this framework in terms of something it owns. So it's in terms of this new protocol. And so as long as something conforms to that protocol and adopts the behavior that this expects, I'm free to refactor everything outside of this framework as long as there's something that behaves like it used to, right? So this thing's no longer tied to how account broker over here is actually implemented, which is a key thing to sort of managing legacy dependencies. So the next step being to inject the account broker into the superannuation. So we create a class here which adopts that protocol and implements it in terms of the protocol expects. It doesn't actually matter that it's just basically forwarding it on at the moment to the old implementation. This could be changed at some point. And then, and the last thing is we configure a startup task. So this app has a mechanism by which it starts a whole bunch of startup processes on application to finish launching. And we create one of those, expose it publicly from this framework, and it expects to be passed one of these as a configuration parameter, as an initialization parameter. So we, during the very first bit of the app, near application to finish launching, we instantiate one of those, pass it to this guy, kick it off, put it in its queue, executes. So that helped, that sort of pattern and variations on this pattern helped a lot in isolating and decoupling the different bits and pieces from the different frameworks so that they weren't interested in parts of the system that they didn't really need to have access to. And good old David Wheeler, I love quoting him. It's like all problems in computer science can be solved by another level of interaction. And that's essentially what we had before, so I just introduced another layer of interaction. But of course he also said, but that usually will create another problem. So, and he's very right. I've just added more complexity and more layers. Hopefully the good of the extraction and modularization of the code base outweighs the downside of the extra layers of indirection. So where do we end up? Well, we got more code in the end. After another 12 months of development, what we've ended up with is about 5,000 lines less Objective-C and 41,500 lines more of Swift. Yeah, so there's still got a lot of, there's still a lot to do in this particular application. We've still got a lot of code to delete. There's still obviously a lot of legacy behavior. We were adding features, we weren't taking them away. And so that team has a lot to do. We do have a much more modular application. It's a little bit easier to just figure out where the hell you are in the code base. It's made up of a variety of frameworks. We can do some funky things like develop an entire replacement subsystem for one of the major functional areas beside the old one and have it essentially toggled off in sort of a build feature. And we actually delete that framework before we ship it. So it's just weakly linked, so it doesn't cause a problem. But yeah, and frameworks let you do that sort of thing. So it has opened up a variety of other possibilities. Basically there's still lots of work to be done, but I'm pretty happy with where we've got to so far. Excellent success.
Are there any questions for Oliver?
So, thanks for the call, guys. That was great. You said you were forcing projects through scripts, and
yep.
How does that work in practice when you check this?
So we have a defined directory structure, and we have rules about what goes in those directories, what types of files. And so just wrote a bash script to check that. And we just put that as a build phase for every framework. It just self-checks basically to ensure that no one's chucked a PNG in the wrong place or whatever. And I also have a policy of no subdirectories, so we check for that. So yeah, there's just, everything's flat file, just in one directory.
Thanks.
I have a question that's more about, I think, stakeholder management rather than pure software. Like all of the strategies and the problems that you have with the code and the strategies that you have to deal with them, I assume, like from someone who's non-technical, it means that you're going to spend a lot of time writing or deleting or moving around code, but not deliver quote-unquote actual value. How do you sell that to your stakeholder? Because I assume, I don't know which bank you're working with, but I assume that there's a lot of bureaucracy and inertia in decision making, right?
Yeah, I think that one, I think if I wasn't in the situation that I was in, it would have been a lot harder. And I think other people on the team would have not been able to do what I've been doing in this particular situation, unless they were very good at stakeholder management. Yeah, no, I've fortunately, because I came in as the first developer on this project, and have a close relationship with some of the key stakeholders, I've had a lot of latitude to do whatever the hell I like. So I think on the delivery side of things, yes, and the stuff I've been doing would have, like, I've not delivered a card in 12 months. So,
you what, sorry?
I've not delivered a card in 12 months. So, yeah.
But do you mean you have like two parts of the team, one part of the team who refactors and changes the code, and one that keeps pushing new features?
Yeah, that's essentially what's happened is that, and that's kind of what I tried to encourage when the project first was founded was to have like a core tech team who wasn't delivery focused. They were just there to ensure that the quality of the app and through the vagaries of organizational reorganization and agile and everything, things got messed with. But now, actually, there is now a core platform team again. So I don't know if they're tasked with cards to deliver. I couldn't say. I'm not actually part of that team anymore. Yeah, I was in a bit of a special location. But if you're a serious sort of tech lead who has inherited a code base like this, you have to make a very strong case that this sort of stuff is necessary. And it has to align with the business desire. Now, the business wanted a more modular application. Like they wanted to be able to do things, more feature delivery, more feature teams and so on, and go and sort of plug in stuff to the app. The app was not in a position to be pluggable, but some of this work helps get to there, and I was able to sell it in that way, in that this is increasing the modularity of the application. It makes it it adds potential. As I said before, we were able to bootstrap and build a whole replacement sort of subsystem in a separate library, in a separate framework, because kind of this work had been begun and started. If it hadn't been begun, that would have been a lot harder. It would have had to if-def everything out or something, which would have been horrible. For me, it created pull request hell for me. Yeah, so one of the other side notes is I only work at this particular organisation 2 days a week, so I have to do all this very slowly, and so you have thousands of commits creep up and behind you, and so it just makes a bit of a problem of rebasing and getting everything to merge and stuff. I'm not sure if it created more pain on the other side, Michael. Right. Yeah. Yeah. No. Yeah. It's pretty impossible to review several thousand file pull request. Flask tries. He's very diligent. He spotted a bunch of my fuck ups. So yeah, it's good to have people like Vlasta who've got like laser-like focus on that sort of thing. Yeah, there's a number of strategies. Had I more time and more, maybe more resources applicable to this, I probably would have done it on a slightly more piecemeal basis, sort of establish certain steps and stuff, yeah. So there's definitely mistakes I made or compromises I made about how to work and do this work, which you are no doubt aware of, that caused maybe a bit of frustration here and there. But yeah.
So how was it dealing with existing developers on the project and the changes you will trigger at that point?
Existing developers on the project?
Yep.
So, well, when the project kind of kicked off, there were no existing developers. So it was a new project with new developers. A few people who had worked on the code previously were brought over, but it was only 2 or 3 of those. But the main, I think if you mean more the other developers working on the project at the time, yeah, I mean, I informed them of what I was trying to do, and yeah, mostly the pain was on my end, I think. Because most people, once a new framework arrives, they're like, oh, all my code has moved into this framework now, I will work in there. Or whatever they have into touch for the particular feature. It was more of a problem of like catching up with people's changes. Like if a code that wasn't in the frameworks already, if people were changing them. And the vast majority of changes I was making actually were just moving files. And fortunately, if you don't change too much in the file, Git's pretty good at recognizing a file change, even though technically it doesn't track file moves. So its heuristics for detecting file moves and things actually are good. So even if people had made quite radical changes to a file, if I hadn't touched those lines, but I'd moved the file to a different location, it didn't really cause a merge conflict. I mean, it might have minor ones, and project files are a bit of a pain, but in general, changes that were happening. And also, as the final graph kind of noted, most of the people were busy off writing Swift code. You know, you don't create another 50,000 lines of Swift code by maintaining the existing 200,000 lines of Objective-C. Everyone was like, oh, Swift, excellent, and doing their thing. And I was mostly moving around all the old Objective-C. So yeah, so I'm hoping it didn't cause too much consternation on other team members.
I've got one question. I've recently deplotted a project, got to move a lot of things around. But I guess just to put all this change in perspective, are you running on iOS, iPhone and iPad? What's your minimum deployment level? Sort of where's your app? Do you still use CocoaPods to manage external?
Yeah, we do. Yeah, so the project still uses CocoaPods to manage the external dependencies, and that works fine. It starts getting, your pod file starts getting a bit complicated when you've got all these extra targets. You're having to import things, and some of the legacy code exported the pods in the headers, so it's a big no-no. So if you've got a framework and it's using a type from a pod, say Lottie, take Lottie for example. So you've got some animation and you want to make an animation view and you subclass Lottie animation view. You have to then import that Lottie framework in your header, and then you want to expose that view and out of your UI kit or something into the rest of the app. What you've effectively done is expose your private implementation detail of using Lottie in your UI kit to the rest of your app. And that causes a bit of a problem with CocoaPods. CocoaPods complains about, well, when Xcode builds the frameworks that don't use Lottie internally themselves, they're all like, where's Lottie? I can't build this module. What's module Lottie? And so you then have to say in your CocoaPod, well, actually the dependency of this target is also Lottie and stuff. You've got to bring that into the header search path for that particular framework target, which is a bit of a problem. Ideally, you don't do that. So if you've got implementation detail like your dependencies on your CocoaPods and stuff, keep it private in your framework. What was this you were saying? Oh, the targets and stuff. It's an iOS 10 and 11 app, and yeah, it's iPhone and iPad, and what else? That was it. Yeah. One more question. Oh, we got another one. When dropping iOS 9, day one.
Did you have to make a business case for dropping it?
Not really.
You just get programmed so that one just has to go through that process himself.
No, 9 was easy.
Yeah. No, we didn't have to justify that. Again, I was in a kind of fortunate position of having a reasonable amount of influence.
So you spent a year to build this beautiful architecture, right?
Yeah.
And the application was started in 2012, right? So 6 years ago.
Yep.
How do you make sure that in 6 years you're not in the same situation as 1 year ago?
I can't. Like it's up to the development team to see the value in what's happened, and if they don't see the value, they'll get back into the same mess they were in before. So yeah, I can only influence a software project when I'm working on it, and by trying to instill a culture or instill practices that people continue after. You know, as a consultant, you're in that kind of situation. I mean, even if you're a permanent employee of an organisation, if you then subsequently decide to leave, anything that happens after you is not really your problem. I mean, hopefully people have learned or have got something out of a value of what you've done and continue to practice those things. But that's the other thing is like things change, right? Like practices change. Bob will talk about like Swift Package Manager. Maybe in 12 months' time, we're all using Swift PM to do manage our dependencies, or maybe, you know, it'll help us build frameworks or whatever. I don't know. It's
best case scenario.
Yeah.
In 6 years' time, you get to come back.
Oh, yeah. Maybe. Yeah, I'm not out of there yet, so yeah.
Awesome. Any more questions about that?
What about non-code, like doc comments or just like normal server documentation? Did you have policies about, you know, if an API has to have
Actually, the practices of the team at the time were pretty good with documentation, so didn't really need to go too far in that direction. We did institute things like SwiftLint and other tools like that to try and keep sort of an eye on people's practices within the Swift code. And we looked at doing using Objective-C linting tools and stuff as well to sort of measure code quality and what have you, but you either have to pay for expensive commercial licenses for things like SonarQube or deal with flaky open source solutions. Yeah, so there hasn't, one of the practices that I did try and introduce, hopefully successfully, is the process of architecture decision records. And I might do a lightning talk at some point about those things. Yeah, documentation and stuff, that's a challenge. But it's not too bad in that particular code base.
Awesome. Thank you all. Alright, so great opportunity to take a break. We're running a little bit behind time, but that's awesome. We'll get started again at 15:15 in 10 minutes. Rob will get started. There's heaps of beers still. See you in a second.
you, sir. Nope. We missed it. Change your code. Can you turn the bottom light switch off, please? All right, guys, we'll get started again. Thank you. Much easier to read. Everybody hear me okay down the back there? Yeah? All right, so lucky last for me, which is excellent because it means I've had a few beers. Going to do an introduction to Swift on the command line and Swift Package Manager as discussed. My name's Rob, or Bok, as most people here probably know me. That's my Twitter handle as well. If you do follow me on Twitter, earlier tonight you might have noticed that I said I was going to experiment tonight. As you can see, I'm attempting to keep the slides and my terminal, and as well as my IDE on the screen all at the same time. As such, here is my presenter's display with a very poorly hacked together app, which has an off by 1 error, so I'm already in trouble. You can get larger text on the terminal, Matt. Does that work? I'm going to go better? Go better. The more I go, the less you're going to have space for actual text.
People are bad. And blind people.
And blind people like you, sure.
Yep.
All right, cool. So, there's my off by 1 error. Hooray! What we're going to look at very quickly, and when I timed this yesterday, I went well over time, so I'm going to skip through a lot of stuff that's not specifically related to the Swift on the command line or Swift Package Manager. But we're going to build a very simple Swift tool. I know it's in front of me. What am I looking at the screen for? Going to use Swift Package Manager. It will accept command line arguments. We'll have some subcommands in there as well, like a git pull or your git clone, that sort of thing. It will accept standard input, and it will execute out other programs. So this is fairly standard application. Where am I up to? Not included. So I'm not going to talk about Swift on Linux. Even though Swift and Swift Package Manager is designed to run on Linux as well, I'm not going to touch it. We're going to import Foundation because everybody loves Foundation. So these are Mac-only command line apps. So this is what we're aiming to do. Now I have to apologize to Matt because I know you wanted me to try and replace Fastlane with Swift, but that was a terrible example. So we're going to do a very simple JSON parsing application that basically lets you minify, pretty print, or render a mustache template using the supplied JSON data, and we'll throw in a couple of the standard version and help options so we can see how that all works. So let's get started. Over on the right-hand side there in the terminal, you can see empty directory. To create a Swift package, we go Swift package init. We specify a type, which is executable. There's other packages, options like libraries and that sort of thing. But for us, we're going to go executable. So just a quick rundown. The package.swift replaces your Xcode project file, manages your dependencies, your targets, that sort of stuff. Your sources directory has all your source in it, clearly. It's usually one target or one module per directory, per subdirectory. You can see you created the JSON subdirectory in there. So that's our executable target. There's a test folder. So yes, you do still have to write tests. You can't palm that off. And then there's a hidden .build folder as well, which is what the Swift Package Manager uses to manage its dependencies, as well as its derived data and that sort of stuff, and a few of the other boilerplate Git project repo stuff. Where am I up to? There, cool. So, brief look at our architecture of this app. It has one target at the moment, which is our JSON target, but the problem with that target is it's not testable. For whatever reason, when you attempt to run tests, you cannot import that, that target. It just doesn't generate the symbols or something similar. So your best bet is to keep your JSON very minimal and wrap everything up into a library target that you can test. In this case, I like to call my base one core. Call it whatever you like, it doesn't really matter. JSON kit? No, because the sole purpose of this target is to do command line parsing and then to call out to the other frameworks that we have there. So I like to put my subcommand logic into its own target so that it's separate and testable, and then the core one just wraps that, basically handles passing arguments, calls the correct framework. Cool. So this is going to be a live demo the whole way through, so let's just hope that this works. Step one, let's add our core package. Now we have an IDE over here. Hopefully, I know you probably won't be able to see the file browser on the right-hand side there, but you should hopefully be able to see the code at least. So inside our package.swift, this is the standard out-of-the-box one. Let's replace it with something a bit more condensed. We have target name, the output binary. Dependencies, we have no dependencies at this stage. And we have two targets. We have our executable target, which is the name of the binary. And we have a library target, which is our core library target. And obviously, the executable target will depend on the library target. So that's all well and good. We then need to go into, I'll do this over here so you can see it. As we said, it's one directory per target. So sources core. And then we're going to go touch sources core. I'm going to create, I'm just going to call it app. We have our app delegate, now we just have app. So back over here, we can see we have our core target. We have an empty app.swift. So let's put some code in there. Now this looks much more familiar for everybody that does Swift iOS dev. Standard import foundation, standard app structure. We have a version property, and all we want to do is accept some arguments and run a function. Pretty straightforward. So the main entry point for your command line application is going to be the main.swift file in the module that's named after your executable. As you can see, default is to print hello world. So let's wrap that up into calling our core. So we import our core, and then literally remember that this whole file is not testable. Better. This whole file is not testable. Anything that's in this target is not testable, so we try to keep it as small as possible. And that's literally create a new app value. By default, we drop the first command line argument because in Unix programming, arg0 is always the name of the binary that's being executed, which is of no value to the code further down the tree. And then we run the app. Optionally, we handle exceptions. If you don't handle the exceptions, it's just going to print them out on standard error anyway. But let's print a nice error message that goes with it. Like, why not? Sweet, so we've done that. Let's go back up here. We can go our two main commands, Swift build, Swift run. So Swift build will go through, compile all of your sources that are in your directory. We'll link it up into a file in your .build folder. Swift run again, just runs it. So pretty straightforward. A good tip that it took me a while to figure out is that you can actually go Swift run, and then your package name will do the same thing. So that if we want to pass in command line arguments to our package, we have to do it this way. Because otherwise it will think that you want to pass it to the Swift run file instead of our binary. Sweet, so, and I'm out of sync already. Excellent. All right, so testing. Let's go back into our package.swift. this time we're going to add a test target. So, same again as before, except this time it's a .test target, and these are all just static methods on the package description and the package setup. We create a test target, we call it core tests, and because we're testing core, we depend on core. Same as you'd set up in Xcode. Same again, we have to, and this gets really annoying really fast, trust me, we have to create test folders. We're going to call it core tests to match our target name. And then inside core tests, we're going to create app-test.swift. Cool. So back in my IDE, inside our core tests, empty app test file. Let's populate that. And this is very standard stuff. Straight like XC test. If you've done unit testing for iOS, this will be very familiar to you. It's nothing different. Testably import our core. We create a test case. We run a test. Straightforward. So next command is, and I'm going to clear that so we have some more room, it's just Swift test. It should go through, compile all the changes we just made, execute our test suite, same as the output you'd see in Xcode. But that gets, a lot of this gets repetitive really fast. So the standard, oh wait, before that, we're going to use our imagination for a while and pretend that the rest of this is nicely tested, because I'm really not going to spend the time to write the test for you. We'll be here for like 2 hours, so.
That's where Git revisions are helpful. Go git check out all my tests.
Yes, that would be good, wouldn't it? Sadly, I'm not that prepared. I spent too much time hacking on my iPad app and not enough time doing my demo project. Sorry, Matt.
Which is quite appropriate.
Yeah. All right, so next up, to make all this stuff easier, we're going to go back to a standard C and Linux environment setup called a makefile. So our makefile is just a wrapper. So you can provide a target name, and then it will execute some command line argument, like command line programs to, usually for building. So let's go into our nice empty makefile, same as always. And we're going to add 3 targets. Just a build wrapper, a test wrapper, but most helpfully as an install wrapper. And that will build a release version, a statically compiled released version of your app, and dump it in user local bin, so you don't have to go and find it inside that debug directory every time you want to test it or to run it. So that's all well and good. So if we come back, default make, just wrap Swift build. We can make test. All good, test still pass, thankfully. And we can make install. So that'll go through, recompile it in release mode. Nice static binary. It's installed to user local bin JSON. And now we can run it anywhere. Now, but I miss Xcode. I said literally nobody ever.
I miss Xcode.
You miss Xcode?
I miss Xcode.
Of course you do, Matt. You miss, not what I meant.
You asked for that one, Bob.
Yeah, I know. So one of the good things that Swift Package Manager does is it actually provides a tool to generate an Xcode project file for you from what you've got in there. So you can go back to using Xcode. And it's straightforward. Swift package, generate Xcode proj. Creates a lovely Xcode project file in our local directory, which we can then open. And then I can go ahead and get rid of TextMate. Sorry, TextMate. You've been replaced. Yeah, I like TextMate, I'm sorry. Sweet. We now have Xcode, yay. And we can build. And we can test. And we can get rid of the debug thing there. When that runs, whoa, that's small. That's test passed, that's fine. But be careful. Don't go messing around in Xcode. Don't mess with your settings, don't mess with your targets, don't mess with your schemes. Because as soon as you add a dependency to your package.swift and you have to rebuild your project, it's going to wipe everything. So it's treated as volatile. Don't mess around in there. Or if you do, as we will later on, just be prepared to let it know that it'll be destroyed at some point.
What about adding files?
Adding files is fine. Yeah, as long as it's in the right place, Swift Package Manager will pick it up. That's the main thing. Put it in the right place. Yeah. And it's SourceKit. We do this for SourceKit. As much as we load SourceKit, we do this for SourceKit. Cool. So next up, let's talk about print. Standard print function's fine for this sort of stuff. But good command line apps are supposed to, when they hit an error, supposed to write to standard error, not standard output. So that way, if you happen to throw away your redirect your output to dev null, you still have your error messages if they come through. But the good thing is that if you actually have a look at the documentation for the print function, it does actually support an output target. So the very last parameter on the bottom there is we can output to a stream, as long as it conforms to the text output stream protocol. If we have a quick look at the text output stream protocol, it's literally just a write. Takes a write method, like that's it. Which means that, and I'm still a bit miffed as to why they don't provide this out of the box, but a file handle, or an S file handle if you're Oliver, provides a few standard input, standard output, and standard error file descriptors that are already available to your program. So we just add a couple of wrappers. One wrapper for standard output, checks for nil, obviously, just writes it to the standard output data, and ditto for standard output error. Cool. Got through that faster than I thought. All right, so let's just go in, and since we can't really see this anyway, inside our core target, can you guys see that? Vaguely see that. So as you asked, Jesse, yes, we can create files. Just make sure that if you're going to build it, your target is set correctly, because anytime you rebuild your Xcode project, it's going to default back to whatever's alphabetically first, which gets really annoying really fast when you do all this work, and then SourceKit's not working, your code won't compile. It's like, oh yeah, targets. Same old. So let's do some logging. Cool, we have a nice logging function. Let's replace this with, so we're putting into our code our stream output wrappers that they're on the left-hand side. And we also have a nice, simple log function. Takes an optional prefix to display before the log message. The message body itself, we're using the same as the print function, and we're just going to accept any, and then just take a string describing that any. But we also have a target enum. So we're literally just compact mapping down the message into a single string, and then, depending on the target, writing it to standard output or standard error. So that means that we can go back up the top, create some nice simple public functions, and remember that this is inside a module, so if we want to use it elsewhere, it needs to be public. Standard log. I like to have a log header as well, to something that makes it more obvious that we've just changed what we're doing. Warnings, which are written to standard error, and then actual fatal errors, which are written to standard error, and then we die. Nice and straightforward. Any questions on that stuff before I move on? No? Hopefully that means everybody's understanding and nobody's bewildered. Seeing a few smiles down the back, so hopefully we're okay. So let's talk about command line parsing, since that's the... Yes, Flaz?
Question.
Yes?
Why would you exit from a log function?
It's intended to be an analog to the fatal error normal thing that you'd normally use. In this case, it's usually just an example. That B is empty. So command line parsing. I come from, same as Jesse, I come from a PHP background and a bit of C background. Standard for command line parsing is getopt. So I did some research as to what the best approach for this is. whether there's some other magic third-party library or you roll your own. Nobody wants to try and deal with an array of strings that could be in any order and then include subcommands and their arguments and try to make sense of that. Luckily, if you have a look at the Swift package manager on GitHub, and that's a bit hard to see, the Swift package manager on GitHub, they actually do expose in their package.swift 2 library targets, so that a lot of the functionality they use internally, including command line parsing, you can actually just pull down from Swift package manager and reuse. Note the big bold warning that says this is an unstable, unsupported API, use it at your own risk. Don't put it into production, basically. But it's there and it works. And a lot of the other ones that are, a lot of the other packages that I've seen, or command line apps that I've seen, depend on this anyway in the long term, because this seems to be the way forward for the now, until we get something properly supported. So, chief amongst that, and what we're looking for here is a utility or a class, I think it is, called argument parser. And as you can see, it takes in an optional command name, and then some usage description that gets displayed when somebody calls for help on the output. So, step 1, let's go into our package.swift, and we're going to add a dependency. Why did you open in a new tab? Because I double-clicked. So let's go in and add a dependency. So we're going to depend on the Swift package manager, because why not? And now we find out how well our internet connection works. So Swift package update, same as you would Carthage update or heaven forbids CocoaPods. Git sub, no. Hooray, internet works. I don't have to use my backup. Cool. So we now have, it's pulled in the dependency. If you want to see it, it lives in the .build folder under checkouts from memory. Yep, so that's the Git repo and then a few other things that live in there as well. What we can do now is Swift package, generate, I should have added hot code for this, generate Xcode project. Warning, oh yeah, we haven't actually added it to our package.swift. So we've we have imported the dependency, or we're dependent on it, but we haven't used it anywhere inside our targets. So where we're going to use it is inside core, because core is going to handle the command line parsing. So if we go back to that one, you'll see we're going to depend on the utility, which is a smaller subset and not the entire Swift package management thing. We really just want basic and utility and their dependencies. And a lot of those dependencies are around Linux compatibility, but that's okay. Cool, so let's try that again. Sweet, we have a new generated Xcode project, and it might be hard to see, but we have a dependencies folder now which has Swift package manager in it, which means we can now go to app.swift. Oops, that's not the right paste. And we can start importing stuff from Swift package manager. So we want basic and utility for what we're looking for. We're then going to start building up an argument parser. Now, most of what argument parser does is done with equality, so this might seem a little bit weird, especially did to me for the first time, but it is what it is. Am I up to the next one? Not up to the next one yet. So let's replace our init. And we create a nice, pretty internal one so that we can dependency inject later on for our testing. But we really just want to create an argument parser with usage info and with the overview. But this is all for the help screen, basically. We then will add in options and commands to it after. So that's where I'm up to there. Excellent. So they also provide in argument parser.pass. That's confusing to say really fast. So let's create a pass method, which really just takes our command line arguments, throws it over to argument parser, returns the results. And the results are then used to do your matching in a second. So let's replace our run function with, we started building it up. We're going to ask argument parser to pass our command line arguments in. Can you see past me, Oliver? Enough. And to make things nice, we're going to catch any argument parser errors. So they've included an invalid option or an invalid subcommand. And they also provide a nice print usage function so that you don't have to go through and then build up the print something, I don't know, words. So we've done that. Where am I up to here? We've done that. Cool. So let's Swift run. So you can see we've changed our message from hi mub to hi dad. So now we get to go through and we wait for Swift package manager to build, which is an excellent time for beer. Yep, you would have seen that. I haven't done anything with the options yet, but that's okay. And then we're going to go Swift run JSON -- help, and we should get the output of the print usage command. So the help is built into Swift package manager. We don't have to add that ourselves. Cool. All right, let's add a version. Now again, they provide a option argument, and this is again done by equality. So we have to capture the results that Swift package manager gives us. But in this case, we want to call parser.add, documentation's on the left-hand side, with our version, -- version. It's a Boolean. We don't really care if they provide a Boolean or not. As long as their value is there, we'll return true. You can also accept strings or integers, whatever you want. Anything that conforms to argument kind, which I haven't gone into detail on. And then the usage help. Yep, done that. Right. So now we come back down to our run. Now, so our options, which is the argument parser.result, they provide a function on there, which is documentation on the bottom, or at least all the documentation they give you. You just call options.get. You pass in the result that we saved from the parser and it does an equality check. If that option is actually set, it will return the value. If it's not set, it returns nil. So we're just checking if the version option is there. If it is, we print out the JSON version and we exit. It's pretty basic, our first command, yay. So, where am I up to? I'm up to there, cool. So if we come back over here and we rewrite our help, we should have a version command in the help. As you can see, switching back to terminal gets pretty old pretty fast. Fortunately, or unfortunately, however you might look at it, if you go in, this is the other thing, it sometimes jumbles up the order of your targets when you rerun, regenerate your Xcode project. So sadly, but with our executable target, we can go in and add, and this top bunch here is command line arguments for when we run it inside Xcode. So we can go -- version, and you might have to take my word for this because it's going to be hard to see. But if we build and run, we should print version number. And let's do this over here so you can see that it's true. Prints out version number. But that also means if you're testing a certain path in your command line code, just add your arguments into the scheme, and then you can just build and run inside Xcode. You don't have to keep switching back out to a terminal to test this stuff. Cool. All right, so I'm actually a bit earlier than I thought I would be. That's good. So let's talk about our first subcommand. So we're going to do input, accept some JSON input, and we're going to print it. Pretty straightforward. Hopefully pretty straightforward. See how well. All right, so back to our package.swift, which is our source for everything. We're going to add in our formatter target so that we can keep everything nice and clean, test it, blah, blah, blah. We need to make sure we depend on it. I forget this step every single time I practice this demo. Multiple times I practice this demo. Usually Swift will complain when it can't say, hey, you're not actually using this framework that you've added. So, and then the other step that I always forget, we need to go and create the directory. So if we then go and Swift package generate Xcode proj, it will generate it, but it'll say, hey, there's no actual source files in there because we forgot to, what do they call it? JSON formatter. Sweet. So if we redo that, we should be able to come back to our project, and we should be able to go to sources, formatter, JSON formatter. Sorry, TextMate. Again, lovely empty file. Let's fix that. So again, it's pretty straightforward. Importing foundation, creating a JSON file structure. We really want to just accept, like all we want to do is get some JSON in. We're going to use the JSON serialization API, not codable, because I don't know what the structure of this JSON might be. It could be arbitrary. And then we have our structure here, which is really just wrapping up. There's a nice way to wrap up the JSON serialization options so that you can pass them from your core target library over to your formatter library. And small tip, when you have a, for each library target, have a unified error API, which literally just wraps any other errors that your code might throw. Why? Because if you're trying to debug something that a user sent you, literally all you're going to get from them is the copy and pasted output from the command line, and all that's going to say is, hey, file not found error. Great, where? Which one? Like in the 10 places that I call the file system, which one was that? So at least if we say, hey, we can't serialize this because there's a serialization issue with the JSON that comes in, we've got a little bit of context that comes back with it. And it's also good for iOS apps too, just for the record. Cool, go back to our pretty subcommand. Where am I up to? Yep, cool. That's done. So all we want to do is to accept data from our core. Very basic initializer, accepts a JSON, optional JSON string for testing, or for if you wanted to be able to bring that in via a different method in the future. And our options from the command line. Happy path, if we have JSON data, we just try to deserialize it. But the key thing actually for this part is if JSON string's nil, we attempt to read from standard input. Now one thing that this doesn't do is that if you are, for example, cutting dev random or you're attempting to tail a file, a stream that never ends into this application, that's going to sit there attempting to read the whole way through. So you need to be a little bit better about handling that. Treat it as a normal stream and process it as it goes. But for a JSON application, if the structure never ends, then it's going to chew up all your memory and die anyway. Probably set fire to your building, but you know. Cool. Oh yeah, and the other thing we need to do, now that we've captured our JSON and the output options, is to actually print it. So that's literally the only thing that this module does, is to print that out. And the good thing about this is you can pass in a file handle. So if in the future you wanted to add the ability to output it directly to a file, you only need to replace in pass in a different file handle to this method. If not, it defaults to standard output. And yeah, standard JSON serialization, grabs the data, writes the data. Easy. Easy, well, yeah. Cool, so back in our core, if we go back to app.swift, so what we're going to do is, now you can do this any way you like. I like to have a nice simple protocol that defines my subcommands. All I really need to know is the data that I pass to argument parser, which is the name of the command, the help text for the command, and hey, I want to be able to execute you with the input from the command line. So then if we go to app.swift, we can add in support for this sort of stuff we're going to accept. We need to keep an array of subcommands because argument parser works off equality for some reason. Oh, there we go. My subcommand file is in the wrong target because it defaulted to basic. Another mistake I made every time I did this demo. That should work better. Yep, cool. But now we need to initialize our subcommands. Whoops. Let's do this with just an empty array of subcommands for now. Yeah, I've done that. And then finally, the only other thing we need to do, oops, no, two things we need to do. We'll add a function to grab to attempt to grab. Let's get rid of that. Takes in the result from our pass function, so we have the command line arguments as known by the argument parser in Swift Packages Manager. We then call, when did I do that? No, I didn't do that. Off by one error. They provide us a subparser function, so the results from the command line argument, you can then pass in the main subparser again, and it will tell you the name of the subparser that it used to process that. It's a little bit convoluted. This is why it's unstable and unsupported. But at any rate, so we're going to get back, hopefully, the subparser that was used. It's an optional, of course, so if it's not found, it's not found. And then we're going to match it back to our array of subcommands that we saved before. So then we need to, so literally our core program is check if there's a version argument. If there's not a version argument, check if we have a matching subcommand. If there's no matching subcommand, we display, hey, invalid subcommand or option. And then we print the usage, and then we die. That's it, because the program did not execute successfully. Error 400, bad user input. If we do get one, we run it with the input from the command line. So that keeps it nice and clean, nothing else to do there. So did I do anything at that point? No? Aha, a whole page of things I missed. No, not really. All right, so let's create our first command, because that's what we're here for. And then we can all go home. We're going to create our, we're going to change our target. That's better. And then so we're going to create a pretty subcommand. Nope, wrong paste buffer. There we go. So again, it's literally just implementing the protocol that we had before. We provide a name, we provide an overview, which is used in the help. And this is the only thing that's a bit weird, is that we accept in the main argument parser, and then we add ourselves as a subparser to the main argument parser with the name and the overview. And we do that because we need to keep a reference to that subparser so that we can actually do our own options matching later on, which is very weird. Where am I up to? 35, 36. Awesome. So we're going to add in one option to this, not with that paste buffer. So our original, we didn't see it on the original slide, but we can provide in a sort our output so that we can see what options look like inside a subcommand. Now, strangely, or not strangely, deliberately chosen. NSJSON serializer's sorted key option was only introduced in macOS 10.13. Unfortunately, all of your Swift command line apps are targeted at 10.10, and it is really difficult to actually overwrite that, so you're better off just conditionally compiling stuff, sadly. That's why we have it as an optional. So if you're in 10.13, we add in the sorted option. Before that, we just don't support it at all. So there's that code, that's that code. Oh yeah. So now we need to have our run. So when we actually execute this command, literally all we want to do, not with that paste buffer. I skipped a step, that's why that paste buffer's there. Uh-oh. Error. No, that one. There we go. So same as what we have to do in our main command processing, we have to do our own checking of the sub-command options, in which case, by default, we want to pretty print this, so we're just going to set pretty printing as our standard for this command. If we're in iOS 10.13, iOS, macOS, and they've provided the sort option, which is -- sorted, we insert that into the writing options, and then we return that option subcommand, that options structure that we created previously. And then to execute, now we're back on track. We get our options with the argument results. We created the JSON formatter structure with the options that we found, and we print. And now, if I'm down to here, that means I can go, the other thing that I always forget. So back at app.swift, in our array of subcommands that we have here, we need to add a subcommand, obviously. So because it's self-contained, we just need to go pretty command, or pretty subcommand, with use your paste buffers. So that's it. We now have a pretty subcommand. We can now go back into, let's do this the nice way, make install, hope that this compiles. Come on, be happy. Yeah, this is from 2012. It's not good. You'll notice I'm plugged in just because the battery lasts 3 minutes. If anybody wants to sponsor me a new MacBook, I'm all here. Right, so we now have a JSON binary. Ugh. And now it has beer on it. This is excellent. Cool. So we have a JSON binary. If we do JSON help, we can see we have a pretty subcommand. If we do JSON pretty help, we can see it has an option. So we can now go cat in our demo JSON, pass it into JSON pretty. Wait, let's show you what's in it first so you don't see there's any trickery. JSON data, not sorted, not pretty. Wow. I don't know, I kind of like how that looks rather than how Xcode thinks pretty looks, but anyway. So let's do that. Pipe it into JSON pretty. Ta-da, output JSON. Hooray. And we can sort it, which just alphabetically sorts it. Cool, so I'm running over time, so I'm going to skip several sections of this next bit because you won't want to see that. Let's do rendering, because this does something that's actually really cool. Now, how far is my paste buffer out of whack? Oh, closer than I thought. All right, so let's go into package.swift. So this last bit, we're just going to look at executing other commands and then displaying the results. That's pretty much it. It will be quick. So let's create a target called renderer, which has no dependencies. This is the trouble with my paste buffer being out of sync. We need to make sure we depend on that target. Render up. And then we need to make sure we create the directory, touch source files, regenerate the package. So if we go into our renderer.swift, render.swift, which is nice and empty. Same as before, this is really basic. It's just going to be accept the JSON input. Now we don't care about the structure because we're just literally going to accept data and send data. We take a template path, so we need to know which template to use to render this thing. As before, we get the data from standard input if it's not there. We have our output function. And then, to actually output, no, one ahead. Yep. So Swift, again, Swift Package Manager provides a nice set of classes for handling, executing stuff on the command line. Sadly, it doesn't support standard input, so I have no way of echoing output into that process. So our wrapper for that, well, so our templating engine we're going to use here is just, it's called Mustache. It's very common. It has libraries for every other language under the sun. But it accepts on the command line a JSON file or a data file that you can then push in. So all we need to do is use the temporary file structure that Swift Package Library also supports. And we're going to do that here. So it's literally just returning a temporary file and encapsulating that error if it's not found. So to build up our output function, we get a temporary file. We write in our JSON data to that temporary file. And the good thing about this temporary file is that, as the note says, the file is deleted as soon as the class or the object itself is de-initted, so that you don't have to worry about cleanup. It just means that you need to make sure you have a strong reference to that. Otherwise, your temporary file might get deleted before you expect it to be finished. So now we've got a temporary file. The process class, we just want to init a process. And it's literally the only thing you need there is the command line arguments that you want to pass to the process, remembering that the 0 index must be the name of the binary or the full path to the binary that you want to execute. Nope, wrong paste buffer again. So that's literally it. We want to call the mustache. We want to provide the path to the JSON file. And we want to provide the path to the template. The other thing we need to do is we need to process the output. So we launch the process here, and then we get our results back. Now the structure of the results file is on the left-hand side. It just returns an exit status, but the things we're interested in are standard output, standard error from the process that it launched. So we get standard output if there's standard output, and then we capture that. We write it back to our own output handler, whatever that might be. As before, it defaults to standard output. Otherwise, we attempt to find whatever's in standard error, output that. Oh, that's well gone. Cool, so we're at the very last stretch here. I can see Matt's falling asleep. You have too much beer, Matt? Yep. So all we need to do is, we need to create a render subcommand and change the target, because of course we do. Render subcommand. Nope, wrong paste buffer. So our render subcommand is exactly the same as the ones you saw before, except there's no such module renderer. Why? That's interesting. Uh-oh. This is what I get for skipping things. There is no dependencies because it's internal. If in doubt, regenerate. I'm in core, right? I'm hopefully in core. Nope, build still failed. Excellent. Oh, great. This is going to be good, isn't it? Let's go find out my paste buffer and what I should have had in there. Of course, in our package.swift renderer, actually, because we're using the Swift package manager, we need to depend on utility as well. That'll work better. Build still failed. Oh yeah, that one's actually a proper error. Yay! Saved. But now I'm way off in my paste buffers. Oh, cool. So literally the only paste buffer that's left is in our app.swift. Let's get rid of that thing. We go in and add a render subcommand. So then we can go back here. We say make install. You can see we have 2 subcommands now. We have a render subcommand that takes a positional argument. Positional argument is the same as the other arguments that we saw, except it doesn't have an option flag in front of it. It just takes the first one off, like the first string coming off the array. So if we go cat demo.json, pipe it into JSON render /demo.mustache, and we're done. That's it. Oh. Apologies, that took a lot longer than I thought it would. But so there was one last thing. Just a heavy reminder, there's no run loop, which means all of your nice asynchronous code will not get executed. You can either create your own run loop. Swift Package Manager provides a nice async function as well if the function that you're calling has a callback with a single result. Or they also have a condition which wraps NS condition. But most of the time, for us, pretty standard, just create your own run loop. Cool. That's it. Any questions? Yes?
Swift Package Manager, is it going to solve all of our problems?
No.
Yes.
Well, ask me again in a month.
This generating Xcode projects, it seems to, the formatting for the file structure that you put in there seems to be a convention. It seems like everything, you've got a dependency there from GitHub. It seems to be everything I need.
Does not support iOS. You can only generate macOS command line stuff with it at this stage, and other frameworks. You can't actually go and use Swift Package Manager for anything that you're deploying via the Mac App Store or the iOS App Store. Well, WWDC is in a couple of weeks.
I'm really hopeful. If I'm excited about anything next month, it's Apple's native fast-paced edition.
It's all public. It's all about the public. Like it's like the copies that want someone furiously working on shit.
Private forks, it's GitHub. But Swift Package Manager might be open source. Xcode is not. And that's where we're falling down because there's no Xcode integration for this stuff. Yeah, feel free. It's like I said, it's open source. Go feel free to make a pull request. Do all the work for Apple and don't get paid for it. But it might be more effective than opening radars, so.
You mentioned that do not go and
not out of the box. I'm sure somebody's tried that on. You could probably add that to, that's probably one of your key things that's good for a makefile, is if you just want to copy out your info.plist and a few other things to somewhere else, saving your schemes, and then putting them back after you've run. But, like, it's certainly possible. Yeah.
I'm interested in how you perform presentations.
I'm glad somebody asked.
How'd you do the cool?
So clearly I wanted to keep, so the goal was to keep, right, the slides and the text editor up the screen at the same time. Sadly, Keynote does not like full screen. Regardless of what you do, it's going to do its own full screen. So that's actually a PDF that you see running on the left-hand side. Sadly, Preview is not Apple scriptable because I don't know. So it's using a open source PDF app called Skim, which does support AppleScript. And then the magic is multi-peer connectivity framework. So you would have potentially seen there is a very dodgy app that I wrote that literally just starts an advertising and stops the advertising, and that's it. That's just advertising a multi-pair connectivity service called Prezzo, because why not? There's no encryption. Like, anybody could have just jumped onto the Wi-Fi and then started joining the session and sending commands, because, hey, I did this in like half an hour. And then this is just two instances of PDF Kit's PDF view. And as you tap the buttons, it just sends through commands on multi-peer connectivity to the main one.
And this is just full screen side by side?
Yeah, so that's just the PDF full screen in single page mode. So all it does, yeah, and then that's just the terminal. So you can see at the top. Yeah, I probably spent more time working this out than I did on the actual demo, but sure. It does all right. I need to get the font sizes a bit better because it was a bit small on the day, but yeah.
That's as impressive as when the first tech set presentation was given. So like, wow, how did you do that? So yeah, it's just in Markdown. This takes it to the next level.
So, well, it's funny you mentioned Markdown actually, because the whole thing is written in, except for the slides themselves. I don't know if you guys follow Erica Sadden on Twitter. She tweeted the other day about a new app called Snippety. That's what lives in the menu bar that I had up the top there, which has all of my paste buffer in it. So that's literally everything that I went through just then. There's a global shortcut key to advance and grab the next paste buffer, and then we just paste. And then I have my lovely cheat sheet, which reminds me of which buffer is on which screen. And so next version of this, I wrote the slide numbers on my form, but I don't actually have the slide numbers on the app, which is an oversight. The off by one error is really annoying, so it doesn't actually show the second slide until you get to the third slide. Yeah, there's some work to do. It's not even an alpha. It's just.
My question.
Sure.
More thanks for being prepared for it.
Yeah, well, I figured somebody would do that. But happy to say, experiment was a success. When I just tested this at home, it froze my MacBook, and it took me 20 minutes to get set back up again. So.
This was a double demo.
It was a double demo, yes, I suppose. Cool. So, any more questions, or can I throw to Jesse and we can go home? Jesse, let's go home. This is still. Was.
Yes, and all that airplay is from Apple TV. It goes out to the projector and out to YouTube. There's a lot of ways. I've got like one slide. I'm not going to talk at all. Next backside.
It's on.
Next Wednesday on next 6. Come along if you've got a project to hack on. Drinks night is the final Tuesday, May 29th. NS breakfast is the Wednesday at WWDC in the morning. Series
watch State of the Union first and then sleep all day.
Yeah, State of the Union sleep come for Wednesday morning. That's the high ground. Next meetup is after WWC back here on June 14th on Thursday. Thanks for coming. See you next month.
Thanks, guys.
And Rob, they were really great presentations. We're back to our last year's
Yeah.
late
Oh well, I said that would happen.